Tomas, good to see you. Sorry we missed you at the CC Summit.
Hi, Nathaniel. Good to see you. Well, I don't see you. I see your name, but I hear your voice, so that's good enough. And,
yeah, my laptop is folded up and in a dock on the side, so the webcam
no problems.
Doesn't look at anything.
Was it good, the CC Summit?
It was good. I had a good time. My talk was well received, and yeah, I've got a lot of good conversations. Met some new people. Met a lot of old people. So, yeah.
Is the recordings? Are the recordings out already, or
I don't know.
No? You don't know?
I don't.
I will get a notification from someone probably. Anyway, let's wait a couple of minutes more. And in the meantime, if you want to fill in the meeting minutes.
I pasted the link in.
Thanks, Kit. Okay. So today we have Anna, who kindly volunteered to present a very, very interesting topic, which is device assignment in TDISP and the binding of the evidence that comes from the device that gets into the workload TCB with the rest of the platform evidence. I think that should be the gist, if I understood correctly. She's going to talk for, including Q&A, 1 hour. So she's going to fill completely the slot, today's slot. And I wanted to ask you whether you want to take the questions all at the end or while you go.
Whatever people prefer. I prefer a discussion, so they can maybe raise their hand and we can have the question right then.
Okay.
If there is something that is going to be addressed in a later slide, then I'll just postpone it for then.
Perfect. I think you can take it from here. And thanks very much again.
Sure. Give me 1 second.
Yeah.
Okay. Can everybody see my screen?
No, I don't.
Uh,
Now something is happening, but it's black. Okay, here you
Yeah.
are.
Okay. Okay, good. Sorry about that. I haven't used Zoom for a little while, so it's fresh. Anyway, so hey, hi everyone. I'm Anna. I work with Microsoft, and I'm part of the Azure Confidential Computing Group. And this is a talk that I did at the Linux Security Summit last week. And the topic is about binding TDISP attestation evidence with a platform attestation evidence. So I'll just go right into that. First of all, I have a primer for confidential computing. I'm going to skip that for this forum. I think everyone is way more knowledgeable in this than me, so there's no point in having that primer. Then I'm going to talk about TDISP. What is the benefit of TDISP? What does it add? How does IO look like without it? Uh, and then with it. Then I have the topic of attestation, and specifically I'm splitting it into platform attestation and TDISP attestation because they are distinct. I'm introducing the concept that they are completely independent. There's no binding as of now for those two. And then I'm going to talk about the proposal that I have for binding them and why I think this is important. Okay. So skipping the confidential computing primer, I'm not sure how familiar people are with TDISP. TDISP stands for Trust Execution Environment Device Interface Security Protocol. It's a specification that defines how can we add a device into the TCB of a confidential VM. The specification has, oh, and I just realized might not be able to see raised hands. I hope I do. But, oh, if you don't, just interrupt me.
No worries, I will arbitrate.
Okay.
Okay.
Okay, awesome. It defines 3 key points. One is how a CVM can establish trust um, uh, for the device, and that is done via device attestation. Then it defines a way to secure the interconnect between the host and the device, so that the communication channel between the host, the CVM, and the device should be protected. And then it defines a way to securely attach and detach a device interface to and from a CVM. This involves a whole state machine, messages to put in the device interface into specific state, which then can allow for device attestation. If everything goes well and the CVM agrees, it can go ahead and accept the device and so on. In order to support TDISP, it requires a lot of changes everywhere in the hardware, firmware, and software stack. It also requires a lot of infrastructure changes, but I don't think it's too relevant for this discussion. Okay, so this is a picture on how I/O is being done in a confidential VM today without TDISP. So before jumping into what does TDISP exactly provide, let's just see without it, how does the situation look like? So in the CVM architecture, the memory is divided into private memory and shared memory. Private memory is only accessible by in-TCB components, so things that the CVM trusts. And the shared memory is only, it can be accessed by out-of-TCB components as well. So things like the hypervisor or the host OS, untrusted devices, and so on. So without TDISP, a device cannot be added to the CVM of the CVM's TCB, and thus can only access the CVM's shared memory. So if we take an example of a SmartNIC type of device, in order for the CVM to use that SmartNIC and do network traffic, the device driver has to encrypt the I/O data take the I/O data from its private memory, encrypted and copied to the shared memory, and then the device can go ahead and access the data from the shared memory region. On the other way around, when data are coming into the CVM, the SmartNIC has to copy the data into the CVM's shared memory region, and then the CVM has to copy the memory and decrypt them inside the private memory region of the CVM. Yes, Yogesh.
Yeah, I have one question regarding, because you are saying an encrypted data, so I assume that the keys needed for encryption decryption are already kind of handshake between the CVM and the device, which is an assumption here, or is there any other channel which is not shown here?
Yeah, so you're correct. There needs to be an encrypted channel already established at this point in order to do this communication. But the channel is not between the CVM and the SmartNIC device. It's between two endpoints. So CVM and, let's say, a server or another CVM or whatnot that is transferring the data to or from. Make sense?
Okay, I mean, I was more interested in saying how does the device can decrypt the encrypted data unless it has some kind of
That's the point. It doesn't. Since the
okay.
device is not in the TCB of the CVM, it should never have access to decrypt to plain text data. It should only have access to encrypted that and shouldn't have knowledge on how to decrypt it because again, it's not trusted.
General though, I mean, what if here the NIC code would say it's a transport, right? I understand that, but what if the device is like a GPU?
I'm sorry, I'm having a little bit of difficulty
sorry.
hearing what you were saying.
I was just saying that here the NIC is like you're basically saying in this picture the device is a NIC, and it makes sense that therefore it's a transport. It doesn't really need to decrypt. It can just sort of shuffle the encrypted data around to the endpoint, like you said.
Mhm.
But is that general? What is that true for all types of devices? And I get sort of a rhetorical question. Maybe I'm sure you answer it later.
So I do have an example of two other types of devices. So I think that for a SmartNIC, that is pretty accurate. If we don't have a TDISP, if we don't have a way to make the SmartNIC confidential, then it should only have access the data as encrypted and just treat it as a blob. Take the blob from one point to the other, right? I have here an example of what would happen for a GPU, because one of the things that, in order for the GPU to function properly, it needs to have access to the plain text, and it can do something like training or whatnot, right? And this is where the problems I think starts to arise, because we need a way. So the computational computing principle is that only in TCB components can access plain text confidential data. So we need a way to add the GPU into the TCB of the CVM. So I do know that NVIDIA Hopper architecture does have confidential computing architecture that is not TDISP. It's TDISP-like, I think, and that is a way to do that. But I think that it's, and this is my opinion, it's not ideal because it's not standard. It's something that is done specific for that. And I also think it's a primer prior to having full-blown TDISP support. So yeah, that's one example of how to try to solve this problem. Another type of device could be a crypto accelerator. Again, this type of device needs to process plain text data. There's no point in accessing already encrypted data that are encrypted from the CVM. So again, in order to support the CVM using this type of device, it will also require some kind of confidential computing architecture in order to add that crypto accelerator into the platform TCB. Hope this answers your question. Okay, so
Yes,
if we
thanks.
want, okay, thanks. Awesome. So if we want to summarize what is the impact of not having TDISP support, for SmartNIC type of devices, the impact is that the CPU has to do a lot of encryption and decryptions of data entering and exiting from the CVM, which consumes CPU cycles, obviously. So instead of the CPU working on the CVM workload, it now needs to be doing this extra encryption and decryption. This can impact I/O per seconds and reduce performance. And ultimately, this increases the cost because the same workload will need a smaller CPU size and possibly less memory in order to be executed in a general purpose VM versus a confidential VM. The confidential VM has to have extra power in order to do those extra operations. Now for GPU and crypto type of accelerators that need to have access to plain text data, the situation I think is worse because they need to have a custom architecture that is TDISP-like in order to add that device into the TCB of the CVM, which obviously raises complexity, and it makes confidential computing also less performant and more expensive than general purpose computing. Okay. So now that we've seen what happens if we don't have TDISP, let's see what the I/O looks like when we do have it. So with TDISP, a CVM can do device attestation, and then, oh, yes, question.
Yeah, hello. I wanted to just quickly understand, like, what's the relationship between the performance and the cost? Can you explain that? I didn't follow the exact reasoning that you have there.
Yes, so since there is so the performance is because you are consuming CPU cycles for doing extra operations of this bounce buffering of data. So now the CPU, instead of doing things that the workload of the consumer, doing the CPU workload, sorry, the CVM workload, it has to do these extra operations that wouldn't be present, for example, if you run the same workload in a general purpose VM as opposed to a confidential VM. The relationship between performance and cost is that in order to try to match the performance of a CVM with a general purpose VM, you have to buy a better, a bigger CPU and a more memory potentially. So a CPU with more threads. That is what increases the cost. Does that make sense?
Yeah, thank you.
So Anna, more than CPU encrypts and decrypts is really the memory operations, right? The related to the bounce buffering that are costly in a sense.
Mm-hmm. Yes.
And for specifically for the smart NIC type of devices, I think before it goes on the wire, we want it to be encrypted anyway, because that's good practice. I think the increased cost here comes from not being able to take advantage of the hardware accelerated encryption, right?
Yes, exactly. Okay. So with TDISP, we can do device attestation. The CVM can examine the device report and decide whether it wants to add it into the TCB of the CVM or not. If they do this, if the CVM does decide to add it, then from that point on, the device becomes trusted and it can access the CVM's private memory directly. So through that error here. So if we take again the example of a SmartNIC, an accepted SmartNIC device can access the I/O data directly from the CVM's private memory, and there's no need for the extra bounce buffering, encryption, and decryption. So that makes the CVM performance much closer to a general purpose VM. I do have an asterisk, anyway, a note here that there are some slight differences that don't make the CVM performance exactly the same as general purpose VM. And one of them is the introduction of ID. ID stands for integrity and data encryption, and it's the protocol that encrypts the communication of the interconnect. So the PCIe link between the host and the PCI and the device needs to be encrypted, integrity protected, and replay protected. That is being done by IDE. So that is something that does not necessarily exist in general purpose VMs. So there is a slight impact of this extra layer of stuff that has to happen for a CVM. So that makes the CVM performance not exactly the same as the GP. Plus, there are other reasons why just a non-TDISP regular CVM doesn't have exactly the same performance as GP. But overall, the TDISP makes there is less cost and complexity to support other types of accelerators. Specifically, for example, the accelerators like the GPU and the crypto accelerators that I mentioned. If they support TDISP, then we have a standard way of adding them into the TCB of the CVM instead of doing custom solutions. Okay, so this is one complicated slide that describes what attestation is. I am probably going to skip over that because I'm assuming that this forum is very knowledgeable on this topic. What I wanted to mention here mostly is to just introduce the concept of the verifier and the endorser and the role of the relying party. I think, yeah, it can be skipped. And another thing that yes, question, Kiri. Sure.
Yeah, hi. Could you be precise on what you consider to be platform attestation? Like, for instance, is it the attestation that an integrated rooted trust provides for the CVM TCB? Or
that's the slide that I have right next.
Okay.
So, okay.
Yeah, but it's okay, but platform attestation has different meanings though. So so if there's an attestation related to what the firmware that the SoC manufacturer provides or any hardware configuration, you're considering that independent of platform attestation then, right? It's only what it's narrowly interpreted to the what's required for the security guarantees of the CVM. Is that correct?
So I consider platform attestation to include. Okay, I consider platform attestation to include the attestation of the hardware. So hardware, firmware, and microcode, and all that, and then everything within the confidential VM. So that would include the VM firmware that it has. It will include the UEFI that the VM has. Not the platform UEFI, just the VM's UEFI, the guest operating system, and any applications that are running within the CVM. That is what I consider platform attestation, just the aggregation of all that. And this doesn't include anything about TDISP devices that might be connected. Just how a plain CVM can function. Does that make sense?
Yeah, okay. Yeah, because if you look at the recommendations for TDISP, right? I mean, the for signed measurements, you could use a dice chain to derive the signing key pair, and that derivation actually has some it has information on the platform TCB. So that's why I was kind of curious as to what you're expecting a separate attestation for. So are you considering that at all in your model?
So to my understanding, when we are doing DICE for TDISP attestation, it doesn't include the platform key. It only includes the keys that are present on the device. So that would be the hardware manufacturer of the device, but not of the CPU, of the platform CPU.
So I'm going to barge it in there, and I'll agree with Anna. I mean, the DICE certificate, there's several certificate change on the device itself. The slot 0 is for the certificate change of the device, and all 7 other slots can be any kind of certificates that we want, representing anything that people want. Someone might choose to put a platform certificate chain in there. I just don't think that's the right place to do it.
Yeah, but it is in my reading of the standard, it is allowed. So
It
I
is.
mean, yeah.
I don't think that would be the most generic way to go about things.
This is not part of the standard, as far as I know. So that would be either we need to put it in the standard and make it so that every TDISP device follows that, and maybe it's a good way to do the binding, or find a different way.
Well, yeah, if you look at the Calypto spec, there's already a derivation of the dice key pairs there. I think what you're saying is that those wouldn't be used to sign the TDISP measurements, and that's fine. That's your assumption, right?
Yes.
Okay.
It also has the problem that if you move that card to a different machine, that that dice cert chain for the platform is no longer valid, right? So you'd need to revoke
Yeah.
slot 1 essentially, or
Yes.
maybe slot 2, wherever you placed this, and then repopulate it for the new machine.
Yes, but that should all be supported
Yeah.
in the device. Yeah.
It
Okay.
would make things very complicated to proceed this way.
Right.
Because of what David just said. It's not the most generic way to proceed.
And
Okay.
also, we're talking about discrete PCIe adding cards here. There's also the entire realm of integrated endpoints as well. That you have all of TDISP and SPDM involved, but you have no IDE at that point because it's all internal to the processor.
Right. Yes, Habib?
So, following up on what Giri was mentioning, I think the platform for how we typically view of this is typically does not include application. So we think of it as workload attestation versus platform attestation. So what I'm hearing from you is that you have both combined together. Is this the view that you have? So you said that you have when you say platform attestation, that includes from the hardware up to the application, including the application itself, right? So is there
Yes, that is correct. Obviously, there is separation within those components, right? Even obviously, Ring 0, like the operating system and the application have different permissions. There's also different permissions for VMPL 0 versus VMPL 2 in the AMD world, where the VM firmware is more privileged than what is running within the guest or VMPL 2. So yes, I agree that there is separation within, there are privilege levels within this attestation. But yeah, for the context of platform attestation evidence, I also include application because, and the reason that I do that is because you can measure applications through the VTPM, and those measurements are going to be included in this platform attestation evidence package that an verifier can use to examine the evidence. Does that make sense?
right? I kind of get that, but what I was trying to think over was a different architecture where ARM has a platform attester, which is separate from a realm attester, and then you have a binding between the two. So they are two separate attesters rather than this kind of architecture where you have in AMD, what you are showing here is the privilege levels separation between the two. So they are two completely different attesters where they have a separate evidence. And I was wondering if that has something to do with the approach that you have. Did something change if I was to use ARM CCK rather than AMD here?
Can I jump in? I think they're the same, Zama. There's here you see a layer test similar to ARM CCA in delegated mode. You have the two keys corresponding to two different attesting environments that measure different things and sign different pieces of evidence. So and they are bound together. So I think it's just linguistic. It's syntactic sugar saying, we have a separation between the two things or not. It also depends on how you look at the verification side of the things where, you have the supply chain links coming in, and you have most likely two separate supply chains that provide the CPU hardware endorsements and ref values and the VM ref values and endorsements, effectively. But, I don't think there's any material difference.
The workload could change independent of the platform, right?
Right, but this is not talking about workload here. The workload would be something completely different.
Would be on top of this. So
right here, I think the application means what you would typically find in a root file system, because the workload that gets downloaded on the virtual machine, that's customer specific. It has to be authenticated something in some other way.
But it could be in certain, confidential container. Yes, in that architecture, you have that exact split, but others, you might ship the workload directly into the OS image, the guest OS image.
And if that's the case, that's exactly what Anna is describing here.
Yes.
And it's part of the realm measurements. That's how we would produce it on ARM side, but other architectures would have the same capability.
So do I understand you correctly that you are saying that the application which is written here is not the user provided application? Is it correct?
Usually it should be before, before the attestation is being done. I mean, that's kind of, okay, that's kind of weird, but because it can be during as well, there can be runtime attestation as well. But yeah, I'm not sure how to explain it. Sorry, Greg?
Yeah, I was just I wanted to remark that we're about, I think, to enter a brief time of a wealth of riches. So Mike Stunes is going to present on kind of the focusing in on the parts of this architecture that are like the AMD 7SP layer and the VTPM layer, in probably a focus dive on that later in July. So this question may be perhaps better discussed during Mike's discussion later in the month. I think Anna has a lot of material still to cover, I think, on TDIS specific and binding, and that's not going to be covered or discussed by Mike. So just
Yeah,
a thought.
I don't think it makes any difference as far as I understand in the binding architecture, or the fact that we have two distinct attestation, I guess, procedure evidence for platform versus, or what I mean as a platform, and then TDISP for TDISP devices.
And I think I'm specifically referring to, we're starting to drill into that box up there application and talking about workloads. And is the workload, what was on the disk? Is the workload something dynamically loaded later, perhaps through a container, et cetera? And I think that's maybe it doesn't even intersect what Mike's going to talk about, but I think it's even more removed from, I think, the area you wanted to talk about. So I just, from a time perspective, I'm suggesting perhaps we park this one and see how Mike may cover this or not in a couple weeks or in a few weeks.
Good point, Greg.
Okay. What I wanted to say in this slide is that we use, for whatever I have here as platform attestation, and we can debate on whether this is a good name or not. But for that, we use a chain of trust where each component measures the next, and the root of trust is the CPU hardware. So the CPU hardware is the one that measures the CPU firmware, the code that runs in the AMD security processor, or in Intel's terms, the TDX module, and it's also the one that measures the microcode. And it's using the platform key in order to sign that evidence. So the next step of the chain of trust is that, given that we trust the CPU firmware to do the right thing, because we trust the platform key, and because it's signed by AMD or Intel or ARM, and we also trust that the firmware has a good signature and good SVN and good everything, then we trust that it did a good job in measuring what comes later, and that would be the VM firmware and UEFI that is running within the CVM. And that would include the virtual TPM, which also has a virtual TPM attestation key. This, in turn, the virtual firmware is used in order to measure what comes above it, which is the guest OS and the application. I'm saying here that part of the guest OS and the application, because we have one part where it's measured at boot time, and then there's another part that is measured at runtime. And what is measured at runtime, it really depends on the policy and things like IMA and systemd, and how they're configured to define how this which parts are being measured. Yes, Jerry. Oh, Muhammad?
No, sorry, I'm here. Are you
Oh.
assuming that the device is acting as an SPDM responder, or are you just assuming that it's that SPDM is not being used in this flow here?
So in this flow, there is nothing about TDISP. So
No, I'm thinking more about the you're going into TDISP attestation evidence, but the slide deck doesn't really discuss SPDM, so I'm talking about the entire presentation. Do you assume an SPDM stack is running on the device?
yeah,
You do?
yeah. Yes, this is part of the TDISP protocol, that the device needs to have an SPDM responder and establish an SPDM channel between the TSM and the DSM.
Okay, so the device will be sending firmware measurements, even though that's an optional feature of SPDM. Is that your assumption as well?
Yes, and I have it on my next slide on what I assume to be the TDISP attestation. Maybe yeah, if I don't cover it there, maybe we can come back to it.
Yeah, no, there was just in the chat window, there was a little bit of a terminology issue. So SPDM is really conveying the attestation, some of the attestation evidence you're interested in, not TDISP itself. So we just, just to clarify. Okay, thanks.
Okay.
Yeah,
Yes.
So I wanted to clarify that what is the exact boundary between the initial measurement and the runtime measurement? If I understand correctly, what you are saying that the third block in your diagram, the VM firmware and UEFI, is the boundary between what you measure initially, and the guest OS and application is what you measure at the runtime. Is this correct?
No, not entirely. There are things from the guest OS that are also measured at runtime. It doesn't match 100%. No.
Sorry, I couldn't follow that. You were saying guest OS. There are
Parts
things in
of
the
the
guest
guest
OS which
OS
are
needs to be measured at boot time attestation.
okay. At boot time. Okay. So the boundary is somewhere in the guest OS between the runtime and the initial boot time variables.
Yes.
Okay. Thanks.
Okay. So again, just want to reiterate, this is what I mean as platform attestation, and this applies for CVMs that don't have TDISP, because maybe the platform doesn't support this. There is no TDISP connected device or whatnot. But this is what a plain CVM attestation looks like. And here is separately what TDISP attestation or SPDM attestation for the confusion looks like. For TDISP device attestation evidence, this is meant to describe all TCP components of a particular TDISP device. So only the device, nothing about the platform. And this contains things like the device certificates, the device measurements, and that would be the SPDM measurements, and the device interface report. I have here how the modified flow would look like. On the top is everything that you've seen so far. And in addition, I'm showing here that the device hardware is the one responsible for measuring the device firmware. That will include the DSM and the TDI config. TDI config is a very generic, I just meant to be everything in the measurements and the interface report. And this would be signed using a device key. Again, this is following the TDISP spec. If there is a different dice chain that is same as the platform that is signing this, that would be a custom solution, I think, just because it's not standard.
Okay. So I'm just going to interrupt
Go.
here.
Yes.
If I may, the device
Yes.
firmware that you're talking about here, is this provided by the SPDM protocol or the TDISP interface itself? Because for as far as I know, the TDISP protocol does not provide any kind of signing. All that signing is provided by the SPDM part.
So my understanding is that the signing is optional.
The signing is optional. I agree. It's optional in the SPDM specification. A device does not have to support signing itself.
Right. And that is because there is already the SPDM secure channel to transfer those evidence from the device to the host and then all the way to the guest. That's my assumption.
Keep going.
Okay. So at the end of this, the evidence land on the CVM, and we can verify that this evidence is correct, meaning that it's actually the one that is reflected on the device. I'm not sure if, and this is where I leave it, that we have the evidence inside the CVM, and right now it's not, they don't have a discrete way to be bound to the CVM. There's just the only thing that can verify that both TDISP evidence, which includes device certificate, measurement, and interface report, originated from a device that is assigned to the CVM that also has, those other evidence about what is the hardware running, what is the VM firmware running, and so on, is that both of them are inside the CVM, and the CVM has ABI to obtain both. But someone outside the CVM, so a remote verifier, has no standard way to say that those two things originated from the same CVM.
There is a way, right? So you could package a LIDA tester with the CVM and let it take care of the binding by signing both the platform and the device provided measurements and certificates together. That might be one way to bind, right?
Sure. Yes, I agree. I agree that that can be a way to bind them together. My goal is to try to find maybe a standard way on how to do that. Maybe something that it's a little bit more generic or whatnot. And I am very open to saying that, maybe the having just an attester that signs them together is good enough. I just want to bring this topic here to the table and debate them.
Yeah, I mean, given your seems to be assuming that there's a VTPM here, right? So this is a crucial bit in the architecture. Then you could have the attestation key for the LIDA tester hosted by that VTPM as well. Maybe, since you have it, you can use it for that purpose.
Yeah.
So what is the use case of having a local verifier that signs both the platform attestation and the device attestation? And how would you deal with the race conditions that would arise out of such a configuration?
So you're talking about a local verifier or a local attester? Because I thought that Thomas was talking about a local attester.
About a LIDA tester that is packaged with the CVM.
So a local
I think I
verifier would be
misunderstood.
something different, right? It would be someone that evaluates and sees, if this evidence look good.
What does the local attester do?
It would be another point here, I guess another block here that
System
needs
daemon.
Hmm?
A system daemon or something like that is packaged in the root effect.
Right, but what's the purpose of signing both the platform attestation and the device attestation?
Is binding the two together, so making sure that this device is assigned. So basically triangulating the thing, right? So this workload is executing on this platform, and by the way, it has attached this device.
Right, which raises my second question, which is what do you do about the race conditions that inevitably, I mean, you basically have opened up a massive door for time of check, time of use, security issues if you are expecting a remote party to verify locally tested devices, which may come and go, right? Because you could attach a device, you could do this binding, and then immediately that device gets unplugged and you get migrated to somewhere else, right? And now all of a sudden you're handing it data secrets, right, under one policy scheme, while you're now executing under a different policy scheme. And so the only way to resolve those is that you have to trust that there's some local verifier that is executing a policy that you agree with, and such that the device will never enter an untrusted state in the future. That's the only way I see to resolve the TalkTow issues.
Right. I'm not sure whether Anna is also considering the migration in this,
So
Well,
typically,
you don't need migration, right? All you have to do is have imagine you have a host that has two devices, one which it can compromise and the other one which it cannot. Okay, and it knows that the guest policy is going to allow either of those devices to attach. So first it attaches the trusted, or the device that can't be compromised, does the binding, sends out a bound attestation report to a remote verifier. The malicious host observes the outgoing bound attestation and waits for the reply to be inbound. But before it hands the reply back to the guest, it detaches the good device and then reattaches a malicious device, right? So now you've had a secret that's been disclosed under one policy, but is now executing under another policy. So the only way that you can ever resolve this issue is that the local verifier that's verifying whether a device should be allowed to be trusted, attached to the VM or not, that policy has to remain good for the lifetime of the computation. Therefore, there's no additional value in actually providing a binding to a remote party, because you basically, what the current state of the device is irrelevant. What actually matters for the security posture is what is the future state of the device.
Couldn't the relying party release to a crypto key that's derived basically from secret material on both the platform and the T-disk device, so that they're no longer connected? Pardon me?
That breaks migration.
Maybe I can try to address your scenario. So let's say again the host attached one device that was the good device to the CVM. In order to be accepted, in my understanding, before it can get accepted by the CVM, the remote verifier will have to verify the evidence of the device. It will make a decision, yes or no. At this point, it will send the result. And you're saying that, okay, this device was never accepted, but it was already removed, right?
No,
No,
I think
I'm
he's
saying
saying that the I think in my
I'm saying
understanding,
that there's two. There has to be
Go
two
ahead.
verifiers in this scenario. There's a local verifier, which is going to allow the device to be attached or not, and there's a remote verifier, which is going to disclose secrets to the trust domain based upon this binding. My assertion is that if the remote decision is based upon this cryptographic binding, in other words, it's based upon the state of some set of devices at some recent time in the past, then it allows for a malicious host to exploit subtle differences in the policy between the local and remote attestations in order to trick the remote party into disclosing data into a trust domain which is about to become malicious.
If I might rephrase, Nathaniel, as the converse, I think I get your point. I think what you're saying is that more valuable than binding these two evidences together and remotely evaluating the combination is that the remote verifier needs to evaluate that the local verifier has an acceptable policy. And if the local verifier has an acceptable policy, then you don't even need to look at the device attestation. Is that your point?
That's not, the remote party does not need to look at the device attestation because it has delegated that part of verification to the local verifier.
It's indirectly attesting the device because the remote verifier is attesting the local verifier policy, and the local verifier policy is being used for the device. I think this is your point.
Would the problem be solved if so in my threat model the remote verifier is the one that says accept the device or not. It also says release the secret or not, but it also says accept the device or not. And the CVM cannot accept the device before it gets that answer.
We're talking about orders of magnitude different latencies between these requests, right? So, imagine if a remote party has to verify every device attached to the system, then how can migration ever potentially work?
I consider this a different problem. And I think that it can be solved differently. It doesn't necessarily have to be. Anyway, okay, so I'm not entirely sure about that. But is there any other issue apart from migration?
My point is, I don't believe that binding actually provides any cryptographic value to the ecosystem. It appears to, but the problems that arise from such a configuration, in my mind, outweigh any benefit that's gained by offloading that device to some remote party. Anyway, that's my thought. I'll leave it there.
Okay, thank you very much, Nathaniel. So time check, we are at the top of the hour. Anna, would you be available for a follow-up on this, since your slides are, you have still a few slides. In fact, we haven't talked about the binding mechanism.
Right,
So...
I'm halfway there. Yes, for sure. Whenever is the next open slot, I can continue the discussion then.
That is great. Thank you very much for your presentation. Fantastic. And thanks for, the continuation that we're looking forward to see. Thanks, everyone. And
Anna, just question, will you be sharing these slides? Is it shareable or?
Yes, and it's already available online. I can send you the link where you can find them.
Okay, great. Thank you so much.
Bye-bye, everyone.
Bye.
Thank you. Bye.
Take care, all.